In this video, I'll be working through the question you see on the screen here from the 2025 Leaving Cert Higher Level Maths Paper 2. I'm going to try and show you how to do this question and not just the solution. So definitely pause and rewatch certain parts of the video if you need to. If you're looking for a different question from this paper or a different paper entirely, you should be able to find a playlist in the description below or have a look around on my channel. Okay, let's get into the maths. Okay, in question 8, we have a square-based pyramid. Now this question comes up very regularly and it's one that you will have seen either in your book or in past exam papers. It's definitely worth learning how to do it because there's a few little tricks that will always come up in this question. And yeah, before I even start answering what Dave asked me or filling in any of the numbers, I'll just point out the main trick is to look at this from different angles. For example, look at the base on its own is a square. And we can cut that into half or different parts. We can put lines across it and make a triangle out of it. Next one, we could look at the whole face of it. For example, A, B here and P. But not just looked in from the side. Like if this is the edge of the triangle, we're not looking like this into it. We're looking flat onto it. That's very important. We want to preserve all these lengths. So they tell us these lengths, they're the same in this drawing. Yeah, think of it that way. We try not to distort those lengths. And another triangle that comes up very often is a chopped one in the middle. Imagine we chopped this triangle straight down the middle and this O here, this O at the center. We'd put, say, O. They ask us about one of them, OB. So we'll put O and B, this line here, and directly above O is the point P, and between P and B is also a line. This triangle is immensely important. These three triangles, obviously there's 4 of these. I guess there's 4 of these, maybe even 8 of them in different ways, and there's triangles down on this one as well. All of these are important. They will give you some of these lengths and you'll have to move from here to here to up here, put them all together to answer their questions in every exam. They'll change slightly, but these will always be important. Okay, let's throw in some of the numbers they give us. They tell us the base of this square is 6. So that's 6, 6, this is 6, 6. All of these are 6. This one here is even 6. They tell us the length of the sides, AP and BP. They tell us all the triangles are congruent. That just means they're all the same. That means this is 11, this is 11, that one's 11, the back one's 11. That's not 11 as we drew it. It's from there to there is 11 if we look at it correctly. For example, here it is 11. For example, here it is 11. But we can't write 11 here. Okay, that's what I was getting at when I was saying about the angle we're looking at it. So hopefully that's clear. I think that's all the information. They basically then want us to find OB. They give us the answer, in fact, but let's assume we don't have it. So what is OB? You'd be tempted to try and get it from this triangle. We have a right angle, we have a length. Missing something there. But O is actually here as well. O is here and B is here. So we can get this length. This is flat. This is the exact same length as this one here. So can we get anything from here? Again, you'd be tempted to go no because it's 6. We don't know this length. We don't know this length. But we can find out this length. We'll just draw part of this square. We'll draw a triangle of this square. And there's OB. OB is right in the middle of this line. And we know this bottom bit is 6. This bit's 6. This is a right angle. I can't find OB, but I can find this whole length. What's this one up at? D, I guess. I can find DB. That's just Pythagoras' theorem. So we'd find DB, the length of DB squared is equal to 6 squared plus 6 squared. We rearrange this. This is 36 plus 36, 72. We get DB is equal to square root of 72. OB is just half of it. OB is right in the middle of this. This is a symmetrical shape. So OB is equal to a half square root of 72. And that's the answer, except they wanted it in the simplest form. Put that in your calculator, it will just change it for you. You're not going to lose any marks for that. But let me just show you how to do it. We want to think of a large number that, a large square that goes into this. So squares are like 4, 2 squared is 4, 3 squared is 9, and so on. I think 4 goes in and 9 goes in, but let's just do one at a time. Let's take 9 out first. Square root of 9 goes in 8 times. So that turns into 3 over 2 square root of 8. We can go smaller though, because 4 goes into that. So we can go 3 over 2 square root of 4 goes in 2 times square root of 2. And square root of 4 is just 2. So that cancels with that. And we're left with what they told us we'd get. 3 square root of 2. Okay, next they ask us to find OP. O to P, and that's where this triangle comes in. I've already done all the real work here by drawing this triangle. This length goes right here. It's just Pythagoras theorem again. It's 11 squared is equal to 3 square root of 2 squared plus this OP. I usually throw in a letter for this, but I'll leave it as OP for now. OP squared. Rearrange this, we get OP is equal to 11 squared is 121. 3 squared is, sorry, this take away, this will be 3 squared is 9, and square root of 2 squared is 2, so that's 18. So OP, sorry, the square root of all this, OP is equal to the square root of 103. And I can't think of any number that goes into that, and I used the calculator and double checked. No number goes into that. That's the final answer. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. In part 2, they tell us about the triangular face PAB, and that's the one I already drew up here. And they tell us that the angle PAB, this angle in here, is 74.2, and they want to use this to find the total area. Or they actually say use this or otherwise, and there's lots of ways to do this. I think earlier on the question I found something a few different ways as well. I'm going to do the same here. I know this is 6, I know it's 11, I know that's 11. I don't need the angle. They gave me the angle, I really don't need it. There's a formula I mentioned earlier, I didn't use it, but I'll use it now. The area of a triangle is equal to, people rarely use this one, S multiplied by S minus A, multiplied by S minus B, multiplied by S minus C, where S is equal to A plus B plus C all over 2. And that's when we know the 3 sides of a triangle. So in this case, A would be one of these sides, say 6. B is equal to 11 and C is equal to 11. Put all that in. S is equal to, let's see, 6 plus 11, 17, plus another 11 is 28, divided by 2 would be equal to 14. So the area is quite easy to find. It's just equal to the square root of 14 times 14 minus 6 is 8. 14 minus 11 is 3. 14 minus 11 is another 3. Put all that into a calculator and we get 12 square root of 7 is the full answer. Oh, sorry, to the nearest meter squared. So this comes out as 31.75, so 32 meters squared is the answer there. Obviously, that's not the way most of you would have done it, because they gave you this angle here. So another very common way would be half the length beside this angle, 6, times the other side, 11, times sine of this angle in here, which again they told us is 74.2. And you put all that into a calculator, you get something very similar. 31.7 something, or 32 meters squared. And there's other ways to do it as well. You could split this down the middle, and you know this side is 3, this length is 11. Use Pythagoras theorem, we'd get 121 minus 9 which is 112. So this is the square root of 112. So we have half the base, 3 times square root of 100. Let me write that down. A is equal to 3 times square root of 112. And I'm guessing that is, does 7 go into this a magic number of times? 70 plus 42, yeah, it goes in 16 times. 16 is a 4. 4 comes out times 3 is 4 times 3 is 12. Square root of 7. Sorry, doing that. I shouldn't do that in my head. Calculator, get the same numbers there. Same answer. I'm sure there's even other smart ways to answer that area. Okay, next part is a construction part. It's a net. How do we cut up a piece of paper and make this shape here? And they started off for you. They say this is the beginning of a net of one of these. How do you construct the rest? Before I show you at least the sort of rough way to do it, because I don't have a compass to do all this. Before I show you the rough way to do it, let me show you a few possible answers, because there is multiple answers. The net of a square base pyramid could actually look like this. Just a triangle each side, fold all that up and you'd get that shape. Problem is they started it looking like this, so that's off the cards. But there's still actually a good few options for you to do here. The one they probably want you to do is something that looks like this. Something that looks like that. That will all fold down. This will fold up. And once that folds up, this will just fold slightly around. This will then fold slightly around to this side. And this will fold slightly around that side. It'll all link together. That's probably what they wanted you to do. But of course there was other answers. You could do, so had to be the two they gave you. You could have put one over this side and another one on either side, or hell, you could have put it down here. You couldn't have put it either this side, because this one's going to go there, that's going to go there, that's going to go there. So you have a few options. I guess one more would be the way they started. You could have here and here. Of course, this has to go there. Or I guess even one more. You could rub that one out. You could be, let's see, something like that there would also do it. So there's a good few options. I'm going to just draw this one, okay? But hopefully it'll give you the idea of how to do any of them. So the main thing I would do is I would point out that all of these triangles, all 4 of these, have the same length. There to there, there to there, there to there. All this is the same length. That screams circle. So what I would do is I'd get my compass and put it from here to here. Let me use my hands like this. From there to there, and I would just start arcing out. And it should hit this point, it should hit this point, and it should stay going on up like that. That's the first thing. I'd put this in pencil all the way around, or as high as I felt I needed. The next thing I'd point out is this length and this length are the same. So again, I'd get my compass, I'd just double check, yes it is. I'd arc off here and mark off a point. There is my next triangle. I'd do the same again, and there is my next triangle. That's full marks for this question. Let me clear all this off and get to the next part. For part B, we really have 2 questions in one. They give us this triangle with these lengths. It's a right angle triangle. And they want us to find, let's see, the angle, which is a CAB. CAB. They want this angle in here. They want us to find that. That's sort of one half of this question. The other half is they tell us this story about a girl, Ali, who thinks the answer is 52 degrees, but she's wrong. And they want us to find the percentage error. So that's the other half. That's what does percentage error mean? That's what they're asking in the second half. Let's do the first part first. Let's find the real answer. So we have a right angle triangle. You should be thinking sine, cosine, tan, all of them. We have this angle, we have the opposite, we have the adjacent. So that fits for tan. So we should look for tan. Let's put in theta here. Tan theta is equal 17.5 over 15. We get the inverse tan of both sides. Theta is equal 49.3987. This is the correct answer. At least to 4 decimal. I like to take loads of decimal places. I know they only ask for 1 later on. For now, I'll take loads because they ask for 1 decimal place in a percentage. So I really actually need 3 decimal places at this point. So be careful of that. I like to just, in the middle of the question, take loads. In fact, I use my calculator to keep the exact answer as I go through it. But if I was writing things down, I at least write 4 or 5 until the end of the question. Okay, so this is the correct answer. Ali got 52. So what is percentage error? Well, it's how much off you are from the real answer. And what I like to remember to do is I find the error. So don't forget about percentage error for a moment. How far off was she? You can get it as plus or a minus, it really doesn't matter. How far away from the real answer was she? So it's 52 minus this, or in fact, maybe more correctly, it's 49.3987 minus 52. But I just take the absolute value. I just want the distance here away. That's the error. So let's see, that's 2.6 something. Let me just check the actual number here. Yeah, that's 2.6013. That's how far away she was. What's that in percentage? We divide it by, well, one of these numbers. Students always get mixed up which one. I'd say it's always the real number you divide by when you get a percentage. So we divide by the real number here, 49.3987. Put that into a calculator and I get 0.05266 or something like that at least. In percentage they want. So need to multiply that by 100. That's 5.266. And 1 decimal place is 5.3%. At least that's what I got. Okay, let me clear that and we'll do the last part C. Right, in part C, we're going to measure the height of a round tower. And this is a very common question. I would guess even a lot of your teachers would have brought you out of the classroom to do this yourself. It's very easy to do. You can even make the instrument to do it yourself. A few things special here. We're going to measure the height of this tower. I think it's Ali again. She measures angles. So at some point here, she measures the angle to the top and she gets, let's put in a dotted line here, she gets 35 degrees and then she goes 10 meters away and she gets 22 degrees. This length from here to here is 10 meters. We're a bit off the ground though. That's because you don't lie down on the ground, do you? You just do it from eye height, but then just measure the height of your eyes down to the ground. And in this case, that height is 1.25. That's the setup for this question. Very common, comes up all the time. Forget the drawing, let's just turn it into simple triangles. The main triangle we're going to deal with is this one here. But of course you can put in this one as well, and that'll be a right angle one. So basically we have 3 triangles. Let me draw them all out quickly, I'll rub them out again. We have this triangle, we have this smaller triangle, that's this one here, and then we have this bigger triangle, this one here. We're going to use all 3 of them. I'll just use this picture though here. I think they give us a letter, yeah, this length here they tell us is X. Let's put in some of these numbers, 35, 10 is down here, 22 is here. This is not H. H is this number plus another little bit. If you put H here, it's fine, you'll get the wrong answer, but if you remember to fix it at the end, you're not going to lose marks. I'll just put Y for now, okay? I'm going to find this number and at the end, I'll add 1.25 to it to get actual H. Okay, where do we begin? You go wherever you want to go. You fill in any number you can think to fill in. For example, we can get a lot of angles. We know 90 degrees there. We know if this is 35, this angle here must be 145. 145 and 22, that means this angle up here must be 13. Let's see, that's 35, that's 90, this must be 55. So we can fill in a lot of things and basically you just stay going like that. In this question they've helped you by telling you to find X. If they didn't tell you to find X, they just told you to find H, you would have found X. You would have had to find X. They've helped, they've tried to hold your hand and bring you through this question a little bit. So how do we find X? Well, look at the triangle it's in. I will draw it out separately this time. We know 10, we know lots of angles. We know 4 things about this triangle. That's more than enough to find out anything. They help us again, actually, don't they? They tell us to use, yeah, they tell us to use the sine rule. They in fact just give us the answer as well. So the sine rule tells us lengths across from angles. So it tells us that x divided by the sine of 145 must equal 10 divided by the sine of 13. So we had to get these angles as well. That was an important step I took there. Rearrange this, we just get x is equal to 10 sine 145 divided by sine 13. Put all that on a calculator and well, they give us the answer there. It's 25 I get 4978, but rounded off to 0.5. Then lastly, we use this to find the total height. I'll draw another triangle. I'll draw the total triangle here. 22, this is 25.5, although I'll use the fully correct answer I have in my calculator. I guess that's all we need. We have whatever other angle we want. I guess we have 68 up here. We want this height here. This is a right angle triangle. We know the hypotenuse. We're looking for, I guess if we use this angle, we're looking for the opposite. So we want sine. Sine of 22 is equal to this length, I've called it y over here, divided by 25.5. And just rearrange this, we'd get y is equal to 25.5 times sine 22. Put that into a calculator and we get 9.5517. I'm not sure if that's using this rounded off number or my exact number, so apologies for that. And then yeah, we just add 1.25 to that, so we would get 10.8 rounded off to one decimal place. I'm guessing that's probably the same answer whether you use the 25.5 or the exact number. Anyway, that's it for question 8. If you have any follow-up questions, or you think I've made a mistake, or I probably have made a mistake if you think I've made a mistake, let me know in the comments. If you could do me a favour and use the timestamp, it'll help me answer the question a bit easier. Thanks for watching and have a great day.